Okay, this is 8.2, linear equations in two variables. Okay, so we've solved equations that only had one variable, usually the variable x. But with linear equations, we're looking at two variables. We're looking at a y and an x in each equation. Okay, so this whole chapter, chapter 8, is linear equations. So we're always going to see a y and we're always going to see an x. We're going to see two variables. Um, Now, these are not hard to deal with, as you will see later, but there's a lot we need to cover today. So, a solution of an equation like this is an ordered pair, an xy value that produces a true statement when the values of x and y are substituted back into the equation. Okay, so instead, when we solved equations a while back, we would find a solution which would be a number like x equals 2 or 3. Here the solution has to be x equals something and y equals something so that the statement here is true. Okay? And that'll become more clear here in a minute. Okay? So we're going to look at these two ordered pairs. For the first one, we're going to see if either one of these is a solution. So I'm just going to substitute. Okay? So I got 2. Now remember, this is x and this is y. So I'm just going to substitute 1 for x and -3 for y, and I'm going to see if that equals 5. Okay, remember this is two negatives become plus. 2 times 1 is 2. 2 plus 3 is equal to 5. This is a solution. Okay, for time's sake, I'm not going to do every one of these, but let's look at this. Let's look at this equation with this ordered pair. So this is x, this is y. So I'm going to plug in 0 for x and 4 for y. Okay, so 3 times 0 is 0, plus 2 times 4 is 8. Does that give us -8? No, it gives us +8. This is not a solution. It's not true. Let's do letter B. Let's plug in -2 for x, and let's plug in -1 for y. Again, we're just substituting. We're going to see if that equals -8. So this is -6 plus -2. Does that equal -8? Yes, it does. So this is a solution. Okay, again, I could do this with all of these, and the way we'll do it in our homework is exactly like I showed you here. So you won't have to write this down, but you have to write the substitution. So use parentheses, substitute the x for the x value, the y value for y, and just see if it's a true statement. If it is a solution. If it's not a solution. Let's look at this. For the 1859 Mauna Loa volcanic eruption, the lava's distance d in miles from the ocean, t hours after it left the volcano, can be approximated by the equation d equals 32 minus 4t. Okay, again, it's the distance from the ocean. So the lava is flowing from the volcano, and this tells us after so much time in hours how far the lava is from the volcano. I'm sorry, from the ocean. Okay, so make a table of solutions for the equation. So anytime we're making a table, and today we're going to make a lot of tables, this is what it's going to look like. I'm going to have my x values here and y. And x is something you choose, y is something that is dependent on what you choose for x. Now notice we're talking about time, so we're not going to have any negative x values. Okay, so let's look at some values here, 0, 1, 2, 3, and 4. Let's look at those values. So to make a table, I plug these numbers in for, I'm sorry, t. This will be t and d. That's probably what I should have done. So we're going to call this t, and we're going to call this d. Now it would be x and y on your graph, but this is t and this is d. So I plug in 0 for t. 32 minus 0 is 32. So it's still 32 miles from the ocean. I plug in 1 for t. It's going to be 32 minus 4, which is going to be 28 miles from the ocean. At 2, it's going to be 32 minus 8, which is going to be 24 miles from the ocean. Do you see the pattern here? It's going down by 4 every time. So 3 is going to be 20, and 4 is going to be 16, right? That's a table of values, okay? We choose the x values, or in this case the t. The y values, or in this case the d, is determined by what we choose here. We substitute these into the equation to get these. How long did it take the lava to reach the ocean? Well, that would mean distance from the ocean would have to be 0. So for this to be 0, this would have to equal 32, because 32 minus 32 is 0. So 4 times what is 32? 4 times 8. So after 8 hours, It's at the ocean. Okay, let's look at another problem. Now we're going to use a table to graph. Just like we did last time, we made a table, but this time we're going to graph. I've got a number of different equations here. We're going to do the first one. So my table of values, we're going to pick 5 values for x, and we're going to see what the y value is for each of these. So generally with x, I choose -2, -1, 0, 1, and 2. That kind of gives me a good start. Sometimes I pick different numbers, but in this case we're going to pick these. Let's start with 0 because that's easy. If I plug 0 in for x, 2 times 0 is 0. 0 minus 1 is -1. So I get -1 for y. Let's plug in 1. 2 times 1 is 2 minus 1 is 1. So if I plug in 1 for x, I get 1 for y. Let's plug in 2 for x. So 2 times 2 is 4, minus 1 is 3. Okay, notice the pattern here. It's going up by 2's, right? Let's just plug in -1. 2 times -1 is -2, minus 1 is -3. Okay, this is going down by 2, so I bet this is going to be -5. Okay, now I just plot these points. I've got 1, 1, which is about right here. I've got 2, 3, which is here. I've got 0, -1. I've got -1, -3. And I've got -2, -5. And notice these should be in a line. So this is kind of hard to do here. I'm going to pick this, and we're going to kind of draw a line. This is not the way I want you to do it, but for me to get it straight here, I've got to do it this way. Okay, so when you graph this, you're going to have something, and I want the line to extend well past your points. Okay, so we're going to have something that looks like this. And then what you're going to do is make sure at the end of your line you've got arrows. Okay, so this is what this graph should look like. Okay, I pick points, I graph it here. Okay, let's do another 1 or 2 of these and move on. Okay, let's see if I can just back up with all of these. Okay, we're going to keep the table, we're just going to do this one. Okay, so let's plug in 0. I always start with 0. It's really easy. 2 times 0 is just 0. So if x is 0, y has to be 0. Okay, let's plug in 1. Well, if x is 1, then y is 2. If x is 2, then y is 4. It's going by 2's, right? So if it's going up by 2's this way, it's going to be going down by 2's this way. Okay? Let me change colors here when I plot the points. So I've got one at 0, 0. I've got one at 1, 2. I've got one at 2, 4. And guess what? All my points had better line up. So I'm going to have one here, and I'm going to have one here. Okay? And again, I'm just going to sketch this. It's going to be a bad sketch, but just to save time, you're going to have a line that kind of comes through here. It's going to fill your graph. I don't want just a really short line. I want a good long line with arrows at the end. Okay? And that's the graph of that. Let's back up and let's do the next one. Yeah, maybe. I'm forwarding it. That's not good. Okay, let's do, tell you what, let's do this one right here, 3x minus 4. Let's plug in 0. So 3 times 0 is 0, minus 4 is -4. Plug in 1. 3 times 1 is 3, minus 4 is -1. Plug in 2. 6 minus 4 is 2. I'm going up by 3's here, going down by 3, so this is going to be -7. This is going to be -10. Okay, and then I just plot the points and draw a line through it. If you're dealing with something like this one, okay, what you're going to want to do is pick numbers that will give you whole number answers. So if I'm having to actually, when I multiply by half, I divide by 2. So I'm going to pick numbers like this that are divisible by 2. So I'd pick -4, -2, 0, 2, and 4. That's going to get rid of the fractions, so I have nothing but whole numbers here. If I had a 3 here, I would pick numbers divisible by 3, like 6, 3, 0, 3, and 6, like that. Okay, and I just plug these in, get numbers for y, and graph these. Okay, for time's sake, we need to move on. Graph the following. Now these are different in that we don't have 2 variables in the equation, but they can still be graphed. If y equals 3, y always equals 3. So no matter what you choose for x, y equals 3. Well, how do I graph that? Well, at y always equals 3. That means every point I put on here, it's got to have y equals 3. Okay, so to graph that, I basically get a horizontal, that's ugly. Okay, I basically get, it's hard for me to go horizontal on this, that's terrible. I basically get a horizontal line that goes through these points. Okay, so let's look at what an x equals 2 graph would be. Don't want to do that. Here we go. X always equals 2. No matter what y is, x always equals 2. That's what this means. So where does x equal 2 at? Right here. Well, if x always equals 2, okay, I'm going to have points all along that line, and I'm going to have a vertical line going through. Okay, so this graph gives me a horizontal line. This graph gives me a vertical line. Y equals -4, that's going to give me a horizontal line. I just got to find -4. 1, 2, 3, that's -4. I'm going to have a horizontal line going through this point, and again, it's a challenge for me to draw this on this pad. And for time's sake, I don't want to get a straight line little tool up here. X equals -3, that is a vertical line. 1, 2, 3. X is always equal to -3. So I'm going to have a vertical line that shows x is always equal to -3. I may be able to draw vertical lines a little bit better on this thing. Okay, so anytime you have an x missing, like these two, you have a horizontal line. Anytime you have the y missing, it's just an x, you have a vertical line graph. Okay, and those are special graphs. Let's look at this. Now, this is the last thing we're going to do. We need to do it kind of quickly. I don't have too much time in this video to do this. We need to solve for y. Okay, so we're going to call it function form. An equation that is solved for y is in function form. Later, we're going to call this slope y-intercept form. Okay, and I spelled intercept wrong. I need to fix that. So what we want to do is transform these into function form. Okay, so to do that, I have to solve for y. So it's like I'm going to solve for this. I need to get rid of everything else. So here, I just subtract x from each side. That gives me 2y is equal to -x plus 6. I like to have the x first when I'm doing this. Divide by 2. Divide everything by 2 when you do this. You get y is equal to -1/2 x plus 3. This is function form, or y-intercept form of this. Let's do this one. Okay, I want to move this over because I want y by itself, so I'm going to subtract 2x from both sides. That's 2x. I get -3y equals -2x plus 3. Divide by -3. Divide everything by -3. And that's supposed to be a 3. It's just me trying to hurry. I get y is equal to, well, that's a positive 2/3 x minus 1. 3 divided by -3 is -1. I'm sorry, this is supposed to be an x. If I can get that. Yeah. Y is equal to 2/3 x minus 1. Once you get these in function form, you simply make a table of values, just like we did. You'll have x and y here. You choose values for x. Okay, now notice here, I've got 1/2, so if I'm going to choose values for x, I'm going to pick numbers divisible by 2, like 4, 2, 0. Here, I need numbers divisible by 3, so I get whole number answers for y. So it'd be like -3, 0, +3, +6, things like that. Okay, so I'd make tables for each of these, and then I would graph. And for time's sake, I've got to get this thing under 15 minutes, so I'm not able to do all that I want to do on this video. But this should be a good foundation, even with all my mess ups like this, spelling error and me not able to draw horizontal lines very good on this pad. This should give us a good foundation for what we need to do in this section. Okay, thanks.